everybody. All right, so let's get the geothermal party started today. Show of hands, how many of you all know what geothermal is? Oh, cool, all right. So we don't have to start from absolute scratch. All right, so Jamie Beard, founder, executive director of a nonprofit called Project Interpace. What I'll do is I'll give you an overview of why this matters and why it's cool and what's changing in the space, and then we're going to invite a panel up to have a discussion about geothermal energy and what the future holds. So let's think about geothermal right now and where it stands in the world where there's a lot of climate angst. All right, so lots of watching ice melt, lots of depressing polar bear footage, and I find this to be a really depressing narrative, right? It's doomerism. Geothermal is a really cool opportunity in an atmosphere of doomerism, because geothermal is a massive and underrepresented opportunity in the clean energy and climate mitigation space that almost nobody in the world is actively talking about, right? So let's back up and talk about what we're talking about, geothermal. We are standing on a massive ball of energy in the center of the Earth. The core of the Earth is the temperature of the surface of the sun. And when you think about that, it means that the heat from the core is literally emanating everywhere underneath us. We are standing on heat. But it turns out that we don't burn our feet when we walk around on the ground. Why is that? Because the Earth crust is a really good insulator. We don't feel that heat, but it's under there everywhere in the world. Now, most people, when they think of geothermal energy, think of stuff like this, right? Surface manifestations. And in some places in the world, geothermal is right on the surface. Volcanoes, geysers, hot springs. We've all sat in one with a glass of wine and thought, wow, this is really cool, right? But it's everywhere. Geothermal is everywhere. It is just a matter of how deep you have to go to get it. So let's think about Iceland, right? This is the place in the world where people really easily associate geothermal energy because it's really, really close to the surface. It's really shallow. And in that circumstance, it's easy to get to. So Iceland uses it. They use it for electricity, and they use it for heat, and also, of course, hot springs, right, that we sit in for on vacation. But geothermal is everywhere. So how do we get to it? And how do we enable it in places in the world where it's not sitting on the surface? Not a moonshot. So this is a drilling rig. The really cool thing about geothermal is it leverages a massive amount of learning that we have gone through over the last century in subsurface exploration and drilling with the development of oil and gas, right? So we're not starting from scratch and figuring out how to drill for geothermal. We can actually transfer knowledge, workforce, and technology from an industry that already exists to make geothermal happen in a bigger way globally. Now, it needs some attention to business models, right? Oil and gas isn't going to do it if they don't think they can make money doing it, right? Oil and gas is a business. And right now, geothermal is expensive. So they're going to have to see a pathway. There needs to be a business model. And we're working on that. There are folks that will join us on the panel today to talk about this. We need some policy work for geothermal. There are barriers that stand in the way right now of geothermal development that need to be removed. And this is, in my view, the hard part, we need to figure out a way to get polarized entities that all like geothermal, but for different reasons, to agree to work together. And this is what I'm focused on day to day at Project Interpace, trying to figure out how to get, say, oil and gas entities to work in collaboration with environmental groups to figure out how we grow and scale geothermal. In my view, a harder problem than the technological problems. Okay? So, what's the impact if we did all of this, right? We scale geothermal, we get folks working well together, what happens? Well, we have a massive impact. How big? Really big. If we were to scale geothermal energy, develop it at the same rate that we currently develop oil and gas. So right now, the oil and gas industry drills globally about 70,000 wells per year, all right? If we drill that many wells per year for geothermal, where would we be by 2050? So let's just say, let's give it some time and start in 2030, right? From 2030 to 2050, we develop geothermal at the same rate we currently drill for oil and gas. What happens? Well, by 2050, we meet 77% of future global electricity demand, all right? And 100% of future global heat demand. That is absolutely massive. And this is an important part, geothermal is heat. And if you care about climate change and you're engaged in this conversation, you'll know heat, industrial heat in particular, is one of the hardest to decarbonize sectors there is. There are no really good solutions to heat. Geothermal is that solution. And if this is surprising, these numbers, 77%, 100%, if it's surprising and you wonder where that came from, you're not alone. Geothermal is absent. It's absent from discussion. It's absent from policy. It's absent from subsidy. Right now, geothermal languishes in the other category in energy penetration models for 2050, right? But the power in that 77% and 100% is the all hands on deck approach, right? It's the ability to get an existing industry that is currently drilling for oil and gas, drilling for heat instead. And if we did that effectively, we could go super fast. We've got an industry with a skilled workforce that's already trained, technologies that already exist, and an existing global footprint, right? That's how we go fast. All right. So it sounds good, but there's some obstacles. The obstacles are currently standing in the way of the massive growth and development of geothermal energy. And there are a few that if we don't work really hard to solve them, they will cause geothermal to fail to launch. And those obstacles are what Project Interpace is focused on. So we as a nonprofit are looking to catalyze movement against those barriers, right? Identifying barriers that are standing in the way, focus really hard on solving those issues, and then allowing a market-based approach, right? We build business models, we get industry engaged, and then geothermal will grow and scale on its own. So let's talk about one of the things Interpace is doing, and we'll run through a few of the programs just to give you an idea of what these barriers are. One of them, where in the world is geothermal other than the places it's sitting on the ground, right? So in Iceland, we see it. There's surface manifestations. When you see a volcano, God, it's obvious. But what about here? Like in Austin, is there geothermal here? How deep is it, right? Most places in the world, nobody knows the answer to that question, and there's no global atlas. So what you're seeing right now is GeoMap Beta. GeoMap is a partnership that Interpace built with Google to build Google Earth for geothermal. And what GeoMap does is combines massive amounts of subsurface data, projects that are being led by a global team of 100 scientists, with Google's surface data. And we put that all into a map that's freely accessible on the web. You press a place in the world, you see the geothermal resources underneath you and what exists on the surface above. So let's look. We launched the first version of GeoMap at COP28 last year. We launched the continent of Africa as our first case study, and let's take a look. This is Nigeria, right? So if you were to click on a place in Nigeria in GeoMap, GeoMap actually leverages machine learning algorithms to do really cool stuff, like estimate building by building energy, electricity, heat, and cooling demand. So you see everything that's going on the surface, and you can also see everything that's going on the subsurface, right? So the goal of GeoMap is not only to engage folks who are just excited about geothermal and want to know what's underneath them, but also developers that are looking to figure out where in the world the demand centers are that could benefit from geothermal energy. So that's GeoMap, and that's one of the projects that Interpace is working on. Next, funding. So a big barrier right now for geothermal, particularly for first-of-a-kind geothermal projects, most of which are being pursued by startups. And you'll see in the videos that are playing here, these are These are actual next generation geothermal startup pilots. So these are real videos of pilots that have happened over the last 24 months in the geothermal space. And really exciting, a lot of teams getting into the field. We have a startup founder here to talk with us today on panel. But one of the things that these companies are running into is an issue with getting their first-of-a-kind projects funded, right? Geothermal is kind of funky. It doesn't fit well into VC models, traditional project finance. It's got too much risk. And you've got a really weird mixture of risk types where there's this valley of death, right, where we can't get projects into the field. But if we did, and we launched a bunch of first-of-a-kinds into the field, that would help us take these incremental approach to get on a massive growth curve, right? So we need to launch the projects. So we're going to talk about, in our panel discussion, how various entities from startups to government can help solve this first-of-a-kind problem. With regard to Project Interspace and what we're focused on in this space, we're focused on very catalytic projects that could really loosen up and catalyze more growth for geothermal pilots in the global south. So for instance, we're looking in the next year to fund a geothermal cooling pilot. And by the way, geothermal is great for cooling too. Complicated, and ask us after how that is. But we're looking to fund a catalytic pilot at a school in India for cooling. So one of the challenges in a very warming world is places in the world that don't enjoy air conditioning because there's not sufficient electricity really suffer, particularly students suffer, when it's too hot to go to school, right? So it's these types of pilots that if we can catalyze one, it'll loosen up a bunch of global scale. So that's what we're focused on at Interspace. All right, so before we transition to the panel, one thing that I'd like to stress, when I say all hands on deck, right, like I mean environmental groups, climate groups, oil and gas, yes. But one thing about geothermal that is a real need right now is new brains. We need new types of people engaging in this space because it's frontier land, right? We're in blue sky territory where there is a ton of innovation happening right now. But we need new entrants into the space. And I don't mean geologists and engineers. I mean, yes, of course, those people. But what I mean is we need lawyers. We need communications people. We need filmmakers. We need artists. We need visionaries. We need thinkers. We need doers. We need every type of person engaging in geothermal, right? And just from a personal standpoint, my personal story, I'm a lawyer. And I knew nothing about geothermal 6 years ago. Zero. And I was hand-wringing when I heard about geothermal, like, oh my God, why aren't we doing this? Why aren't we doing this? Why aren't we doing this? The world should do this. And one day I realized, well, hell, like maybe I should just try to do it, right? And I'm here. And what that means is, God, find a door to bust down in geothermal if you're excited at all about this, and do it. Because there is an enormous opportunity right now for people to enter into the space and have a massive impact. Okay, so if you have any questions about that, after the session, myself and the panel will be outside, and we'd love to chat with you. But for right now, what we'll do is we'll transition to our panel discussion. So I've invited a really interesting mixture of folks here today to talk with us. We've got Cindy Taff, who is the CEO, a former oil and gas veteran, 30 years, vice president at Shell, who left oil and gas to start a geothermal company. And they're just about to build Texas's first geothermal pilot, right? It's just gotten funded, and they're going to break ground on that pilot. So she'll talk about that. We'll talk about the role of startups and how oil and gas veterans are engaging in the space. We have Barry Smitherman. Barry is a lot of former things in Texas, but really importantly, former railroad commissioner. So that's the oil and gas regulator in the state of Texas. Also former PUC commissioner, so he's a grid expert. And he's turned chairman of a newly formed Texas Geothermal Energy Alliance. And he's going to talk about what role the states might have in pursuing and helping support geothermal. And then we have Jonah Wagner. He is from the White House Office of Science and Technology Policy. So there's a federal role here. What is that? And how is the federal government going to build as we go? All right, so with that, I'll invite the panel onto the stage. One note, folks, if you want to use your app, the Slido app, to ask questions for the panel, I will get those on the screen, and we will transition to audience Q&A at the end. So welcome, panel. All right, y'all. Y'all ready to launch?
We're ready.
All right. All right, so one thing I'm going to do is I'm going to pick on Cindy. So, because Cindy's going to be the first person I ask a question to. Cindy has been dubbed by Wired magazine to be a badass. And if you don't believe me or want to know why that is, just look at her. So this is Cindy at one of her Texas geothermal demonstration pilots. Cindy would love to chat with you first. All right, so let's talk about startups. When you decided to leave the oil and gas industry and start a geothermal company, what were you thinking? So let's walk through how the oil and gas industry could engage in this space, why you did it personally, and what you're seeing in this way.
Yeah, no, thanks, Jamie. I'm really a nice person. I'm not a badass. So I was always intrigued with the energy transition when I was at Shell. My group actually did all of the cost estimates for geothermal wells. We were unconventional oil and gas, but we did the cost estimates because we could drill the wells the fastest and the cheapest. And by the way, drilling for geothermal is the same technique, same equipment, same methodology to drive costs down as what you do in the oil and gas industry. But I noticed that we never pulled the trigger as a company to actually drill the wells. We did the cost estimates, and then we never would drill the wells, which actually kind of frustrated me because I wanted to get into the energy transition, but I wanted to use my many years, as Jamie said, in the oil and gas industry, leverage those skills, whether they're the drilling skills, completion skills, the skills for driving costs down so that we can drive, again, the cost of electricity down. And so it's just frustrating. The other reason I wanted to get into renewables as well is I have a daughter that's passionate about energy, and I wanted her to have choices to get into the energy industry landscape that were other than oil and gas. And so two of my partners, people that I knew at Shell that were brilliant in inventing technologies, called, and I jumped.
So what's it look like for you in the next 5 years at Sage? What's the plan? And tell us about the Texas pilot.
Yep, so we have gotten funding, seed funding, and now Series A funding. We're going to be doing this pilot just south of San Antonio. We're hoping to be commissioning it at the end of this year. We're having a little bit of challenge getting the electrical equipment where you really need to plug the electricity into the grid. So we're really good about drilling the wells, building the facility, but we had a blind spot on how much time and effort it took to get the approvals needed to plug that electricity into the grid. So we'll have all of our stuff ready. Again, it's going to be a 3 megawatt facility. We'll be leveraging all of the skills that we know from oil and gas. So yeah, we're excited about that. So 5 to 10 years. Once that facility is, basically generating electricity, we can operate it for 1,000 hours, 2,000 hours. We can kind of get the DOE stamp of approval that says you're proven technology, and then we want to scale. We've got energy storage solutions. We've got geothermal baseload solutions. We're actually working with the Department of Defense. They're wanting to have a secure energy supply for their all of their bases, and they really like geothermal. So what they're doing is they're looking at different geothermal companies out there, not just ours, but others, and they're kind of putting more horses in the race so they can see whose technology is going to be leading the effort. And so we've got 2 projects going on with the DOD as well for geothermal technology. So,
awesome. Thanks,
yeah.
Cindy. So you actually, you've created a good segue into a question for Barry. So you mentioned the difficulties connecting with the grid. That sounds like a regulatory, a permitting, some kind of something problem. So let's talk about that. So Barry, Well, maybe start out and give us a landscape of what TextGea is, for one, why it's needed, and then the state's role in figuring out how to remove barriers and help get projects like Cindy's online.
Well, thank you, Jamie. Good morning. For those of you not from Texas, welcome to Texas, the energy capital of the world, past, present, and future, and you're going to see why throughout this discussion. We've always been a leader in oil and gas. We've recently been a leader in wind, soon in solar. In fact, last Sunday, 80% of the electricity on our grid was produced by renewables. 71% came from wind and solar. But after Winter Storm Uri, which happened in February of 21, we saw the need for a firm, dispatchable, low-carbon energy resource. And so TextGea was born. So we are a trade association with a cross-section of supporters, oil and gas, production, operators, utilities, power generation, startups like Sage, and many others that are interested in finding this, maybe this magic pill for firm, dispatchable, low-carbon energy. So as we began to think about it and talk with legislators and stakeholders here in Texas, it became readily apparent that dispatchable firm energy was very important. We didn't want another Winter Storm Uri. So we began to talk to members of the legislature, regulators like the Railroad Commission and the Public Utility Commission, and it was clear that this was a niche that needed to be filled. So we think we're well positioned going forward. Projects like Cindy's and others are going to demonstrate the viability of geothermal. We have great geothermal resources. I know you were showing a map earlier, Jamie, about the continent of Africa and other places, but actually here in Texas, great resources. Some of them are deeper than others. They're close to the load, close to Houston, San Antonio, east side of Dallas, Corpus, even Austin. And so we're really excited about it. We had a great legislative session. As you know, here in Texas, we meet every other year for 140 days, maybe something the federal government might want to emulate. It works out well for us. And we look forward to the future. We think that as we begin to educate and inspire people to understand geothermal, that this will be a meaningful part of our energy resource in the not too distant future.
Awesome, thank you, Barry. Well, so let's segue. So that's a perspective of an oil and gas state, a state that's an energy epicenter currently. So let's talk about what the federal government's interest is and engagement is in geothermal. So Jonah, tell us what the current position of the administration is with regard to geothermal, and then what are some of the ways to engage? What's the plan from the federal government side to support the growth and scale of geothermal?
Yeah, thanks, Jamie. So just to zoom out for one moment, though, and give some context for why I'm on the stage. Most folks haven't heard of necessarily the White House Office of Science and Technology Policy, but we oversee the U.S. government's science and technology agenda writ large. So we sort of sit at the intersection of innovation and then also the emerging clean energy industrial strategy as underpinned by CHIPS and Science, the Inflation Reduction Act, and the bipartisan infrastructure law. So connecting the dots between those two. As you all know, as everyone knows, President Biden has set a bold ambition when it comes to decarbonizing the grid by 2035 and the economy by 2050, all while creating good paying jobs and affordable, reliable, secure energy for the country and for all Americans. And as Barry mentioned, clean, firm power is going to be a major part of this. We are seeing a significant amount of growth in electricity on the grid now for the first time basically in decades. This is being driven in part by a generational increase in domestic manufacturing as inspired by the President's Investing in America agenda. About a 2 times increase in investment, inflation-adjusted investment since the President took office in domestic manufacturing. This is a big deal. And then also we are seeing utilities starting to update their integrated resource plans off-cycle to accommodate the rapid increase in data center growth a huge part of which is driven by, seems to be driven by artificial intelligence. And against all of this backdrop, you have utilities that are retiring no longer economic fossil energy assets. And all of this is contributing to this really profound need for more clean, firm, dispatchable energy sources like geothermal. And one Department of Energy report, actually there's a couple now, that suggests that we're going to need on the order of 700 gigawatts of clean, firm power by 2050 to support the decarbonization of the grid and the economy. And just to put that in perspective, the entire US energy system today in terms of capacity is about 1,200 gigawatts. So this is a big number. And geothermal, this is not a new technology, right? It's been around. It's a proven, clean, firm resource. And I think what's different about some of the technologies that we're seeing, like SAGE, and when we talk about enhanced geothermal or these next generation technologies, is the way they expand the available resource. So America today is I think has the largest geothermal footprint in the world, about 4 gigawatts, 3.7 gigawatts of capacity. The total available resource for traditional geothermal in the US is estimated, that's in the money, is probably about 40 gigawatts. If you look at the potential of these new technologies, they increase the available resource by 2 orders of magnitude plus. So from about 40 gigawatts to 5,500 gigawatts or more. And that all of a sudden turns this into a resource you can imagine putting in a lot of different places. And we've got some new research, I believe, that's going to be coming out from the Department of Energy in the next couple of weeks that's going to say something on the order of this technology has the potential to provide anywhere from 100 to 300 gigawatts of capacity on the grid in the United States by 2050 if we're going to decarbonize the grid. So you ask, what's the federal government's interest in this? This is absolutely straight down the fairway something that's going to be critical to enabling the president's investing in America and clean energy agenda.
So what about $1 billion? How about 10? Like how can we dump money on the space, particularly for pilots?
Dumping money on the space.
You got the hard question, Jonah.
I would like to refer this one to Congress somewhere. The reality is that there's a lot of things that are actually going in geothermal's advantage on this front, right? So we've got this is a proven technology, we've got an existing supply chain, we've got an extraordinarily talented and experienced workforce in the oil and gas industry to draw upon. And we know how to do this well. We also know that a lot of, for example, if you take data center players, they're so hungry for electricity today, they're willing to pay a premium. And even today, power purchase agreements for geothermal are on the order of $60 to $100 a megawatt hour. We are starting to see the learning curve kick in, even for I think, did you mention the Forge project?
Nope. Go for it.
All right. So the Department of Energy back in 2017 commissioned a project called Forge, Frontier Observatory for Research in Geothermal Energy. This was in 2017 in Utah. The U.S. government has spent about $200 million between now and then, focused on enhanced geothermal specifically, and in particular hydraulic fracturing and horizontal drilling techniques. What we've seen since 2020, when we've started testing a series of these pilot wells, given the speed at which we're able to do these wells, each of them is about 3 to 5 megawatts, drilling rates have improved about 500% in 3 years. So the cost, and drilling is a huge part of the cost, and Cindy knows this better than I do. So I think the opportunity here for the U.S. government is not how do we it's not just about dumping the money in, it's for how long and how much and where. Because right now, and just one more little note, is that in the bipartisan infrastructure law, there was, I think, on the order of $80 million for geothermal pilots, 3 of which were awarded in the last year to Chevron New Energies, Mazama, and Fervo. And Fervo, I think, is based right at the Forge site in Utah. That was $60 million, all towards basically demonstrating a technology. Because if you get enough reps, if we can get enough reps, we can move down the learning curve, and all of a sudden, by 2030, this is going to be a technology that's in the money and that is competing head-to-head with other available substitutes. And so I don't have a magic bullet. maybe one more little note in terms of government resources that are available. So my alma mater, I guess, was the Department of Energy's Loan Programs Office before I joined the White House, and that program exists in part to bridge from those first demonstration projects to the first of a kind commercial and early of a kind commercial deployments that we need to see in order to scale. And it's a low-cost debt provider. It's a very big program. It's got about $500 billion in projects already applied. I know there are geothermal projects in that pipeline, and I'm hopeful over the next year or two that that'll be a big additional contributor to moving these projects forward.
Awesome, thanks, Jonah. So two panelists have mentioned, well, for one, some of the startups that are being mentioned by panelists, Sage, yes, but also Fervo. That slide that I showed with the video of the pilots, those are actually pilots from those startups. So for the Fervo pilot and also the Sage pilot, so pretty cool. Two panelists have mentioned data centers, and this is a really interesting way to connect with audiences that may not be super savvy about geothermal. Every time we use our phones and take a picture and store data, every time we send an email, we are creating digital garbage. We're creating digital space. And we are creating digital space at a massive rate globally right now. And so data center growth is a huge thing. And this is just to store what we're creating now. This is not considering the fact that AI is going to really throttle that need for data storage and usage and energy demand for that source, right? So data centers are one of the big focal points for geothermal simply because there's going to be so much energy needed to power them, and they need stable power, right? So it's a way that we all contribute to future energy demand, right, just by using our phones. But so two panelists mentioned data centers, and it's interesting. Interpace has actually built a partnership with Google, and that's also related to data centers, right? They are a partner with us on GeoMap because they're planning data center growth globally, and they themselves will benefit from knowing where geothermal resources are, so they can site data centers where there's good resources, which I think is a really, really cool and forward-looking thing. Cindy, from a startup perspective, how have you? I mean, are you hearing data center stuff, data center buzz? Tell us what you're hearing on that front and how you've engaged with technology companies.
Yeah, no, data centers are huge. You know, you could make a business out of just providing electricity to data centers. It may not be obvious, but if you layer AI on top of data centers, it makes data centers even explode further. My background's not data centers or AI, but the need is huge. And as you said, Jamie, there's companies out there that they need to start building those data centers now. They need to have electricity to power those data centers. I think the technology companies are also cognizant of they don't want to necessarily take electricity away from other needs, you know, because you still have the business needs, community needs, and so they're wanting to place these data centers where they're not impacting other electricity needs. I would say right now, at least for the companies that we've been talking with, they're actually not wanting to pay a premium yet for electricity for their data centers. And maybe that's just because, you know, solar and wind have done such a great job at greening the grid, guys, and they've brought the cost down. So over the last 15 years, the cost for solar and wind has come down tremendously. And I think that's where we are in geothermal. I think in the next 15 years, we're on that learning curve that it's where wind and solar was 15 years ago. But I think we can drive that cost down. I think it is going to be quicker than 15 years. And I think we can, as Jamie's saying, we can definitely provide energy to these data centers and to the AI and clean energy. And by the way, it's baseload energy as well.
Thanks, Cindy. So, all right, Barry, another question for you. Geothermal and how it plays in traditional energy, oil and gas states. I love the point that you made about the last legislative session and how geothermal fared when other renewables actually suffered in the session. What do you see as the So various groups engage with geothermal in different ways, and I kind of mentioned this in the introduction. Polarized entities, environmental groups like it for a specific reason, oil and gas likes it for different reasons, but everybody likes it, right? What's the terminology? So why does oil and gas like it? And what is the terminology that's used in states like Texas to explain the opportunity in geothermal without turning off, the right? The people that may be not supportive of other renewables, but that do find a way to like geothermal?
Yeah, great question. Just to give you an example, so this last legislative session, we had 3 principal bills that we were moving on behalf of the geothermal industry. One was clarify who owns the heat. You might think that's a simple question, but it wasn't. Number 2, consolidate all the jurisdiction for permitting at the Railroad Commission. And 3, allow geothermal operators to adopt orphaned or abandoned oil wells. Great public policy. Those 3 bills went through both chambers of our House and our Senate, signed by the governor through committee. We had over 500 yes votes, and we had 1 no vote the whole time. I'm still trying to figure out who the no vote was, and I've been able to track that person down. But nothing passes like that anymore. There is nothing that gets that kind of bipartisan support, even in Texas. And so we were able to do that. I think it was the message and the messenger. We had messengers who were comfortable and familiar with the oil and gas industry, with the power gen industry. The message was that this is dispatchable 24/7. It has an on-off switch. It just happens to be low carbon. And that message resonated well. It's sort of like, Jamie, when we were building out the transmission lines for our wind energy, which we did from 08 to 13, we built 3,000 miles of 345 kV. That's why we're the #1 wind energy state in America. We never talked about climate change. We talked about portfolio diversification, economic development, having a resource that was Texas-made, Texas-owned, that complemented our other resources, and we were able to do something I think would be almost impossible today. So the language is important, the message is important, and we were able to have a big tent where we actually had people from the environmental community who were on board. We had consumers on board, and I think it's a template for perhaps what other states could do.
Yeah. What do you think about that, Cindy? So when you message geothermal to investors, what's your angle? What terminology do you use to sell the concept?
I'm not sure if this is a trick question.
No, it's not. What I'm getting at is the because I see it too when I'm speaking with groups, but you have to use different language to attract different types of groups, right? So what about funders? What are they getting excited about?
Yeah, I mean, we're pretty transparent on what we're doing, technically, operationally. What we're talking to the investors about this is a clean, renewable power. It's, like you said in your intro, it's everywhere beneath your feet. You can't drill everywhere for it because sometimes you have to drill to 30,000 feet, and we just don't have the equipment to do that. But if we can crack the nut to what Jonah was saying on this new generation geothermal, which means that you don't have to be in California by a geyser, you don't have to be in Iceland by a volcano, and we could just do hot, dry rock, then we can put geothermal just about anywhere, and we can make it commercial, and we can complement, again, what the great thing that solar and wind has already done, but it is a baseload energy, and it's also dispatchable. And we can also use it for energy storage. So there's so many flexibilities around geothermal technologies. The other thing I think you mentioned is we've already got the oil and gas industry. We've got the infrastructure that can go out now and drill these wells. And so everything is poised for a huge growth in geothermal. We just need to get the money out there to do these projects to get it to the point where it's commercially viable. And that's just testing the technology, and as Jonah said, re-engineering it so we can get the cost down.
All right, so let's talk about impediments to scale, barriers that stand in the way for scale, and how we get there. Money, we know, so that's the easy one. Well, Jonah, you may want to speak to money, but money we know is an issue in geothermal, and just for the audience's benefit, geothermal is massively under-resourced. It has been for decades, but in terms of government spending and support for geothermal, it lags very, very, very far behind in comparison to other renewables like solar and wind. So, resource availability in the geothermal space, the whole ecosystem is driven by scarcity, right? And you cannot innovate in scarcity. We have to find resources to support. So what does the panel, and I'll ask each of you this one, what do we have to do to support scale? Like, what is the impediment to massive growth and scale? The type of scale that we're talking about that will really impact the future of the world. Big, big, big shit. How do we do it? Sorry, Cindy first, then Jonah, then Barry.
My view is we need to take this new generation geothermal, we need to make it commercially viable and cost effective. We're this close. And when Jamie talks about needing money, we only need the money to prove it, to get past this stage where we have new technologies by different companies that are being tested. One of these technologies, or several of these technologies grouped together, is going to break us through. Once we break through that barrier, then the money is no longer needed, because then you're a viable energy source. And so we have to get this to be commercially viable in the next few years, and I think we are literally right there.
Jenna?
I agree. I think we're literally right there. I think of all the technologies that we're looking across in the emerging clean firm space, geothermal's path to scale is maybe the clearest. It's not totally clear, but there is a clear path to scale, and part of the reason for that, we've been talking about the learning curve, the way technologies get commercialized. If you actually look at why solar and why batteries and why these costs have come down so fast, a huge part of it is driven by the nature of, as you sort of expand your manufacturing base, as you make more repeat deployments of the same exact things. I think pick your Lego, what's the individual piece that you're building up towards. I think the opportunity is to basically, you hit a point where you've achieved cost competitiveness, and then you can totally ramp. And there's a report that I think is going to come out in the next couple of weeks from the Department of Energy that's going to say something on the order of, we need somewhere between 3 to 5 gigawatts of enhanced geothermal or next generation geothermal deployed in the next decade or so, which is about $20 to $25 billion of total investment. Putting that in perspective, that is less than the cost of the Vogtle nuclear plant that just came online that my old office, the Loan Programs Office, financed. But this is for the entire geothermal industry, because if you actually divide that 3 to 5 gigawatts across 3 to 5 megawatts per well, that's a lot of wells that we're drilling, right? And that's a lot of learning every single time to get faster and faster loops so that we can get a lot move down that learning curve. So I think the opportunity is to basically cross that threshold, and then we need to do it in a way that proves out different geographies. So for example, the way that the geology of the earth works, you actually have to, it's not because we're finding different types of hot rock to prove this. One of the theories of the case is moving sort of west to east across the U.S. If you could prove these technologies in, call it 5 to 10 different geographies, all of a sudden you've got a use case that banks are going to be lining up to finance, like private capital is going to move in at scale. And government's role is to sort of catalyze that, but a lot of the opportunity is right there, poised for liftoff. I'm honestly very, very optimistic. One small challenge that I would note is, I think something that Project Interspace is very involved with, and the partnership you mentioned at Google is so important, Jamie, is around the subsurface characterization of the heat. Because right now our understanding of the subsurface is basically what the oil and gas industry has discovered. So I think, for example, Texas has about 56,000 different measurements of subsurface heat across the state. Georgia has 29, period. Right, and so there's just a vast difference state by state around how well we understand what's going on beneath our feet, and I think the more energy and research that goes into this, it's going to move us down the curve and get us moving faster.
Yeah, thank you, Jonah. To that, we've drilled over 1 million wells, and we've been drilling wells in Texas for over 100 years. So we have a pretty good understanding of what the world looks like below the surface. Jamie, I would add one thing we really need is regulatory efficiency and predictability. And we hear from our members that are trying to do business in California or Nevada that it takes 4 or 5 years to get a permit to initiate a project. And then after they get that permit, it takes a couple of years to get a permit to develop the project. And I told one of our members, I said, I'm sorry, it's not going to be 5 years at the Railroad Commission. It's going to be 3 weeks. That's what you need. You need to go forward quickly and efficiently and predictably. One of the challenges that we have at the federal level, Jonah, this is not about you, is that, we've been changing administrations every 4 years. So at the Railroad Commission, which now has regulatory authority over geothermal, one of my former colleagues just got elected to her 3rd term. So she'll been there 12 years. So it's that kind of predictability, regulatory efficiency. Look, we don't want to do things in a careless way, but we want to go forward without unnecessary delay.
Thanks, Barry. So we have a whole lot of questions from the audience. They're really good. We have about 10 minutes left in the session, so we're going to segue to some of your questions. If you have a question, plug it in now, and we'll take a look. We'll try to get through as many of them as we can. There are a couple of really good ones, and I know that there are some opinions on this panel about these particular topics. One of them is one that comes up quite a bit with our philanthropic donors. So just for background, Interpace is funded largely by climate philanthropy. And, wealthy donors that are environmentalists and largely left-leaning. But we engage and collaborate with the oil and gas industry. And that does create a lot of discomfort, right? We end up in this polarized space, right? And so I feel it all the time in terms of interacting with our donors. And so I think that the panel will feel this one as well. One of the questions is, well, why can't we just pair geothermal drilling with oil and gas drilling at first and do co-production while we're learning? And that sounds incredibly reasonable and rational, however. So, Cindy, maybe you can comment about that because I'm sure that has come up in your discussions with funders. What do you say?
Yeah, absolutely. No, and it's a good question. It's a question we get all the time. Can you repurpose existing oil and gas wells? Our Starr County well, which is our test well, is actually a gas well that was drilled in 2008 to 19,000 feet, by the way, 235 degrees C. It was drilled in 2008, what is that, 16 years ago. So the oil and gas industry knows how to drill. It was an exploration well, so they didn't run the last string of casing. So we had the opportunity to go into this well with a string of casing that's 10-inch. If they had ran the last string of casing, they would have run 5-inch. So unfortunately for oil and gas, the small 5-inch casing is fine, but for geothermal, you need this huge mass flow rate to get enough heat to the surface so that you can economically turn the heat into electricity. So yes, we can obviously leverage the oil and gas industry to drill these wells. Repurposing existing oil and gas wells is difficult. Now, we have talked to some potential oil and gas operators about drilling their future oil and gas wells bigger so that once the depleted hydrocarbon, the wells are depleted of hydrocarbons, you can repurpose it to geothermal. So that I think that could be a future strategy.
Have you run into, I've heard from several startups that funding entities have declined to fund their technologies because it's possible that that same technology could be deployed for the purpose of drilling for oil and gas. So say cool drilling technology that could go faster, deeper, harder for geothermal, but we won't fund it because it could possibly be used to develop oil and gas. Have you run into any of that dynamic?
We haven't because, again, we can deploy and scale right now with just off-the-shelf, and that is our strategy, to use off-the-shelf oil and gas technology and equipment. So we haven't run into that. We have investors that ask, well, what if you hit hydrocarbons instead of geothermal? Now we're looking at the rock that is just the opposite of what oil and gas looks at. We want a very low permeability rock. We don't want any natural fractures, whereas oil and gas, and actually some of the other geothermal technologies want that permeability and that, the fractures, which actually increases the exploration risk. So we're not going to be targeting any formations that would traditionally have oil and gas in it. So we wouldn't even expect to co-produce oil and gas. So we haven't had that challenge, but we are a different technology than
Yep.
what I think what you're talking about.
Got it. Thank you. There's a good one for Barry here. I'd love for you to address it, Barry. Texas landowners, Texas oil and gas landowners, how can they engage, be proactive, get engaged, and start throwing in on geothermal in Texas?
Yeah, great question. This is one of the issues that we tried to resolve last session. For those of you who are in this space, we have a mineral estate and a surface estate. So generally in Texas, there are two different estates. The mineral estate is dominant over the surface estate, but the legislation we had passed says that heat is owned by the surface owner, just like groundwater is owned by the surface owner or pore space. So one, be aware that if you're the surface owner, you own the heat. And now it's also possible, we haven't gone down this path yet, maybe Cindy has, that if you're the surface owner and you own the heat, you could also sell heat rights to another party while retaining all your surface rights as well. So you have some optionality. It was an issue that had never really been teased out till last session. So one, be aware, know what you own, and that it has value.
Thanks, Barry. Joan, I'm tempted to ask you this this tax credit question, and this comes up all the time in discussions about current available incentives, if they're working, if they're sufficient, what we need, how we need to change them. Do you have some thoughts on IRA, current production investment tax credit incentives for geothermal, and what might be needed to really full throttle ahead?
Yeah, so geothermal will benefit from the IRA, much like other renewable or clean energies, in particular through the tech neutral tax credit. I think, as I think we've discussed, and that's a good thing. Hopefully, I think it's stimulating investment. It remains to be seen the pace at which this happens, but geothermal is on a pretty steep decline from a cost standpoint. I think just a few years ago, the wells were being drilled at a cost of around maybe a little bit higher than $30,000 per kilowatt overnight construction cost. I think in the last few years it has fallen to about half that, closer to $16,000 per kilowatt overnight construction cost. The Department of Energy has set an Earthshot goal for enhanced geothermal of ultimately a price of electricity of about $45 a megawatt hour. At that price, this is a very competitive technology for clean firm. That would imply an overnight construction cost of closer to $3,500 a kilowatt. So we got a ways to go, but the trajectory that we're on actually is going to put us in the early 2030s well on the path to probably a price of around maybe $60 to $70 a megawatt hour. And if we can get down to $60 to $70 a megawatt hour, like, this is a competitive technology, full stop, in particular for some of these energy hungry data centers and other sort of heavy 24/7 carbon-free electricity consumers. So I think it's a bridge period. I think more demonstrations are needed, certainly, and I think there's concessionary financing that may be necessary, or low-cost government financing like the Loan Programs Office to support it. But I do think we're on a very good path here.
Let me answer this from a state perspective. So last session, and approved by the voters last November, the state of Texas now has a low-interest loan program for firm dispatchable power generation. The rules are being written currently by the PUC. We think that geothermal should be able to participate in this. There's also another program that will be a look back to performance during periods of scarcity. It's called Performance Credit Mechanism. Joshua knows about this. And it's possible then that you could be rewarded for being on the grid during a scarce or tight period. So those are a couple of ways that the state is trying to incentivize those that have an on-off switch.
Awesome. All right, so we have 4 minutes left. I want to do a closing round with all of you. Same question, but just want to hear your varying perspectives. And it's more of an oracle type of question because you all come from different backgrounds. Where do you see geothermal? What's your best guess on the resource and where it stands by 2030? So where are we going to be at the end of the decade? And I mean in terms of scale, where we are, how it's growing, who's doing what. What do you think? We can start, Cindy, and go down the line.
Yeah, I hate to say the caveat is, but the caveat is how much money can be invested in the near term. If we can get the amount, and again, Jonah mentioned it again, it's a temporary, it's getting us past the bridge so that geothermal can be commercially viable. If we can get that funding, I think geothermal could, be 30% of the energy mix.
By what, 2050? By 20 when?
Yeah, well, I mean, again, it depends on the level of funding. If you got a lot of funding and you were able to crack that nut on new generation geothermal, okay, maybe 30% by 2030 could be.
That's going to be a hell of a ride.
It is, but you mentioned oil and gas drill 70,000 wells per year all over the world. So maybe it's a stretch goal, but it's possible.
Thanks, Cindy. Jonah?
Oh, I want to get on the Cindy train. I think I'm a little bit more conservative. What I'd love to see for geothermal is if we could double the capacity of the geothermal footprint in the U.S. today. Again, U.S. being the largest in the world, to about 8 gigawatts. So 4 gigawatts of enhanced geothermal by 2030. I think we are way out of the gate. I do want to make one more point that I really hope the geothermal industry learns from the lessons of the past here is around how important the social license to operate is by engaging with communities and with local stakeholders to make sure that people really understand this technology, especially when we talk about things like hydraulic fracturing and horizontal drilling that in the past in the oil and gas industry have not exactly gone entirely swimmingly in terms of public reception. So I think there's a real opportunity to get it right the first time for this nascent industry, and I hope that there's just as much of a focus on that community engagement and sort of conscientiousness that's going to be needed to get this technology off the ground at the pace that we really need it.
That's excellent. Thank you for making that point, Jonah.
So wind went from 0 to 25% of our energy in 20 years. Solar went from 0 to 6% in 3 years. We're an 80 gigawatt system here in ERCOT. I think we're going to 100 by 2030. I'd like to see 5 gigs of dispatchable geothermal on the grid by 2030. That would be the equivalent, approximately, of our nuclear fleet today. So that seems like the right number for me. If we can get to that, then we're a player at the table. We're meaningful. We are at the level that nuclear is now, and we will then quickly surpass it.
Cindy, get going. You got a lot of drilling to do.
5 gigs.
We're ready.
And that's Texas. You're talking Texas
that's
alone.
Texas.
Okay.
All right, panel, well, thank you. So I just want to point out to the audience that I think this panel is a microcosm of what we could build in geothermal, where you have an oil and gas state and the federal government and a startup all rearing and ready to go, thinking that they're aligned to build a thing, right? And this is the hope in geothermal, is threading that needle and finding a way in a bipartisan way to walk this walk and make this happen. So thank you very much to the panel. This has been super fun. I really appreciate it.
Thank you. Thank you.